everybody is itching to get their phone out. So we try to make it interactive. You can scan the code and join the slide. I would recommend you do that. It will make the experience much better for you. And excellent session before me. I think you already set up the stage for me to talk through what I wanted to talk through. So my name is Rohit. I like running, so I've structured it in a way that we can all go for a run together. Before we start with the presentation, a little bit of a story. So because we always start a presentation with a story. So, and this is a borrowed one. So there are two fish swimming in the sea, going from left to right, young fish. And there is an old fish coming the other way. So the old fish asks the young fish, "Hi boys, how's the water?" The young fish have no answer, they swim on for a bit, and then the one fish says to the other, "What the hell is water?" So this is from David Foster Wallace, actually. The speech is called "This is Water," and the intent is not that I am the old fish telling the young fish on what really machine learning and AI is, but the idea is sometimes things are right in front of us, and we don't see them, and that is what essentially I want to kind of talk through when I go through this. So let's start with a run. This is the agenda. We will have a little bit of break the ice session, do some stretching, because you get hurt if you don't do that. A little bit of jogging where we'll set the theoretical framework. I think some of it will build on what Ekta was saying earlier, not by design, but by accident. Then we will have a quick trail. I have a use case where we will take some of the frameworks that we talked about earlier, SHAP for instance, in practice. We'll talk a little bit of what this means for Gen AI and how we are trying to address it at Rolls-Royce. And then we cool down. You can actually post your questions during the session through the interactive thing, and we can just take them towards the end. Yeah, so we'll start with Winnie the Pooh. I just want to gauge the room on how many developers and how many non-developers and how many heads and how many practitioners and decision makers. So few words which come to your mind when you hear artificial intelligence, and the only thing is don't put artificial and intelligence. Good computation, future, jobs made easy, jobs made redundant, jobs made difficult, testing, maths, agentic AI, classification, a lot of good answers, ChatGPT, fake, automation, some excellent answers going on there. So there is somebody saying Jadoo, which is also good to know. So there are a lot of variety of audience in the cloud. There is dystopia, so maybe some writers in the cloud. Opportunities, efficiency, excellent. Lot of good things going around. So we have a varied group. We understand a little bit about where we are with Gen AI. I'm hoping sessions earlier than mine have already helped bridge the gap. So we'll take a step back. You have heard about models, I'm assuming. Some of you have built them, some of you have used them, some of you have seen, talked about them. How often do you consider interpretation of a model? So if you are using ChatGPT, how often do you think, why is that answer coming out? Should I go back and check? If you have a team which gives an output to you, do you go back and check why did that answer come? If you are developing, do you go and see why did my model tell me what it told me? If it did tell me anything useful. This is where interpretation comes in. Of course, there are a lot of people who use it all the time. Some people know about it, haven't used it. And there are some who haven't actually come across it at all, which is all fair. This is what you expect. It is, even though we are buzzing and there is a conference around AI, it is still a relatively nascent field. When I say relatively, I mean with respect to some of the things which we are seeing, like banking, aerospace, have been in existence for hundreds of years. People trust them. People trust us with their lives. So there are systems which are older than AI, and I think it makes sense. It's a fair division. Just one final bit before we get into the actual stuff. So, and I think the earlier presentations have probably helped with that. So give me like few words, first word that comes to your mind when you hear interpretable or explainable models. I'm hoping to see some SHAP, not fear, trust, futuristic. I think interpretation is supposed to take some of those things away, remove the fear, remove the distrust, allow for us to use these models much better. Yep. I think lot of good answers there. It does allow us to make it more reasonable, allow us to trust it. I see some SHAP being mentioned here, non-biasness, understandability. We will talk a lot about all of them. So with that little bit of introduction, so that is me. I went to IIT Roorkee back in 2007, did some work in mechanical engineering there back in the day, then started doing turbo machinery design with General Electric. I got some patents there, so that picture is actually a silver award for getting 10 patents in a year. Then I went to Rolls-Royce. And the picture on the right-hand side there shows a model that we built during COVID. Airlines were suffering. There were no revenue, basically, and we were trying to see how to stay afloat during the 3-month, 6-month period. I do write, so the picture on the left bottom is the one that I wrote, and the right picture is what I am reading currently. So if you are interested in that, again, little bit of product placement, personal things. So time to stretch. So here I think we'll go a little bit into why explainability is not as pervasive as it should be. There are various reasons for that. We will cover them probably one by one. So one of those is it finds its origins in social media. So the cost of not getting a like or your feed correct on Facebook isn't too high. It is possible to iterate quickly and, like Mark Zuckerberg said, right, move fast and break things. It doesn't translate to all the other fields. Another probable reason is a lot of explainability comes from controlled experimentation in medical science. So a lot of data science, statistics particularly, comes from medical experimentation, where you can actually control and have your control set and your placebo set, let us say. And you are able to define what data you are working with very well, which bakes explainability by design in data selection. Again, one of the reasons it isn't very popular is because, like Ekta was saying earlier, so if you do know, if my loan application gets rejected, and I know that had I bought a credit card, my application would have been accepted. There was actually a real case in the news some time back. So a person bought a credit card, got the loan, defaulted on the credit card, left it back, just to get the score up. There are instances where people can misuse explainability. And the cost of operationalizing explainability is something which we don't talk about. Machine learning is supposed to make things cheaper, makes things go faster. Explainability can cost you anything between 30 to 200% extra. So a model that I'm going to talk about, it took us three times the effort and the cost to explain it than to build it. And we don't account for that when we are defining projects or allocating budgets like a lot of you are. So then why interpretability? If there is no reason for it to be there, and we have genuine reasons for it not to be there, why really do we care? And what do you think in the fields that you work in? Is there really a need for interpretability, or is this all just mathematical mumbo-jumbo? Satisfaction, business buy-in, actionable insight, no idea, fair point, actionable and regulation. Regulation is actually a good point. We will be talking about trust, insights, avoiding errors, needed for safety in the systems. Again, one of the things we'll be talking about. For determinism, which is actually the word itself is gaining quite a lot of popularity after Meera Murati's paper. I don't know how many of you have read that. Gaining trust and fairness, a lot of good points. We'll be covering some of those. So this is why explainability matters to us at Rolls-Royce. We have complex systems. The picture that you are seeing there is taken off the internet, not a real engine. But a real engine can be as complex or more than what you are seeing there. It is safety critical. So the picture I have that put there is something called a safety cheese model. I'm not sure how many of you have come across. But you try to put in layers of safety so that if one aspect of it is missed, it gets caught somewhere else. You don't want to fly in an aircraft which was designed completely by AI with an 80% chance of landing safely, right? That makes no sense for anybody, and it is heavily regulated, which it should be. So now we start to jog. Why explainability? So again, this is a picture of the internet without machine learning. A lot of you may not be as familiar because it is so pervasive now, but there was a day and time when we used to have systems without machine learning, explicit instructions, and then you got all this data, started feeding it into systems, and now you have machine learning. The right-hand side picture hopefully will appeal more to developers. I have personally created models titled model _11 final, etc. So that is what we will call as model. Generic things like XGB or language models is what we call learners. So just a little bit of terminology for when I'm referencing to them later. So you know what you know till you are building these models, and then there comes a point of time when you don't know. So you ask a model. This is actually a very famous reference to a radio show turned into a book called Hitchhiker's Guide to the Galaxy. Not sure if people are old enough to remember that. In the book / story. They build a supercomputer. They ask it a question, what is the meaning of life, universe, and everything? The computer thinks for generations, comes back and answers 42. So the answer to life, universe, and everything is 42. Now you ask to explain it. The don't panic word is actually on the cover page of that book. So go ahead and read it if you are interested in that. This is where interpretability comes in. And it has nothing to do with maths, it has nothing to do with models, it is to do with people. It is the degree to which a human can understand and explain the cause of their decision. I've drawn a very straightforward picture there. It is in no way quantitative, but we will look at how to quantify that. So you go from a decision tree to Gen AI. In general, your explainability drops. Yeah? With me so far? Okay, so we start looking at a little bit of the technical things before we get into the use case. So we have the real world. You can never capture the real world in data, so you have a subset of that already. You build a black box model, which is a subset of that data now. Now, before you go to the smiling human at the end, if you don't have any interpretability methods, chances are high the human at the top is not smiling anymore. So there are 5 ways at Rolls-Royce we consider, which are ways to interpret. Of course, there is transparency of the algorithm. So if you can make your model straightforward, if it is a linear regression model, you can look at all the coefficients by design. Then you try to do global and local interpretability, some of which we'll be talking about. And it is more important for us to understand what is the output of interpretability, because it is for people that interpretability matters. So these outputs is what we call explanations. But before we get into that, I have realized any complex technical presentation should have an obligatory tree chart which shows all the different methods thrown around. There is a reference in the end if you want to look at it in detail. But you look at interpretable and model agnostic explanations, so 2 classes. Some things are by design interpretable, and some things you need examples for, or global and local references. So all the theory set, I'm hoping we are doing well on time. How many of you joined the sessions hoping this will be about Gen AI? You can vote. There are some people who were not there, but I see one raised hand. Okay, so roughly 50-50. Some of us were expecting other things than Gen AI. I do have content on Gen AI. Of course, you have guessed that by now. So first, let's talk about Gen AI then, before we get into the example. So there are 4 fundamental challenges that we see with Gen AI adoption when it comes to explainability. One of which is the scaling paradox. So the more complex your model is, the more difficult it is to explain by definition. Second is model access. Doesn't get talked about as often, but a lot of good models are proprietary. A lot of open source models are available. Again, depends on what we really call open source. Sometimes we don't know where the data is coming from, for example. We don't really have access to the models. Third challenge, I think the one most talked about is hallucination in some form, reproducibility. Does the same prompt with the same model give you the same answer? If it doesn't, is it really science? So one of the fundamental tenets of science is reproducibility. Are we moving away from that? And what really is the definition of good? So the outputs, benchmarks that exist in the real world, do they really apply to your industry? Are you only looking for summarization or mathematics? But you are looking for something more complex. So what really makes it good? So from that point, I promised we'll talk about explanation. So what really is a good explanation? There are 4 aspects to it. First of which is contrastive. So why was your loan application approved and mine not? Can a model or a human looking at the model answer that question? Second is selectable. So again, you can make out the slide is older. Team India is doing much better now. But there was a point of time when they were not. And could you attribute it to poor batting or to conditions or losing the toss? And could you select them? Could you say in your model, had we not lost the toss, still had the same batting and the same conditions, would we have won? Is a model able to explain that? Is a model able to do that analysis? Social. This is a classic example, bike rentals. Some of you would have seen it if you have done courses on YouTube or Kaggle, etc. So higher temperatures in New York lead to higher bike rentals. I'm not sure in Bangalore if you have higher temperatures, does it lead to more bike rentals, or are there really any bike rental situations in Bangalore? So an explanation has to pass the social test, which means when you are talking to other people, they should be able to appreciate and understand that as well. And the fourth bit, ability to explain the abnormal. I'm sure a lot of you have come across this example earlier, so I'll not go into the details. Target did this years back. You keep beer along with diapers because new moms don't go out to shop, right? It is an abnormal situation. Is your model able to explain that? So those are the four fundamental tenets of a good explanation. These are not methods. These are checks that you can do for any explanation that you are generating. Not all of it needs maths. Not all of it needs models. But this is the framework through which you can operate. So again, a little bit of like gauging the developer mood. These are different types of models. L/S here means large or small language models. There are decision rules, naive Bayes, KNN, tree-based, different models. So just I keep missing this. So just put which of these is the most interpretable that you have come across. There are some people who are trying to game the system, saying language models are the most interpretable. Generally, tree-based decision rules, we see them as being interpretable. When there are examples nearby, KNNs, for example, are more interpretable. Probabilistic models, somewhat less so, naive Bayes. Language models, even more so. So language models are like naive Bayes on steroids, if you get what I mean. So probabilistic models, difficult. Deterministic models with examples, easier. Kind of tells you the four things that I talked about. This is where we run into SHAP. I think some of you have seen the name at least earlier. Have you come across this? I have a use case where I talk through different elements of SHAP. So we'll see how much time we spend on that depending upon how this looks like. So a lot of people have never heard of it. Some people have actually used it in production. It looks like we end up polarized distributions everywhere. So I'm struggling to see a normal distribution in real life, which is what we were taught in all the statistics classes. Okay, so we'll not spend a lot of time on it. We'll go real quickly. So now this is the time for interpretability in practice. I hope you are all ready. Before we get into anything else, this is the problem statement. The background is supposed to look like gold because pretty much in every engine, we have some components that fail and we are not able to explain why they failed. So we build in safety, we do inspections, we keep margins on life, etc., 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 to make sure it remains safe. In one engine, when you put multiple components, some of them fail and some of them don't, even though they are supposed to be identical, you struggle to explain why. If it is variation between engines, you can explain. So engine flying to Delhi, I don't know how many are here from Delhi, but an engine flying to Delhi in winter will definitely gain more dust than it would in Bangalore. So engine to engine variation, we understand. Component to component, we are trying to understand, which is where this comes in. Little bit of reference picture, because I don't think, I have talked to a few people around, sometimes Rolls-Royce brings the image of like a luxury car. That is not the Rolls-Royce we are talking about. This is aviation engines. So under the wing of the aircraft, there is the engine setting. In that engine, there is a blade that you see there. Some of them are like spread around circumferentially. So 60, 70 of those components are spread around circumferentially. They can fail in different ways. This is where we come into different aspects. I will skip through this really quickly because I think everybody has already seen it. But SHAP, one key point to take away, SHAP importance is different than permutation-based importance. It is mathematically more sound. So try to use it more than permutation, even though it is costlier. You can do instance-based predictions. So you can look at one blade and say it got predicted as low class. What was the actual percentage of that being true? You can understand contributions. So contributions tell you if the average population was the yellow line, the four things that made it to be more susceptible to failure and the four things that made it to be less susceptible to failure. And you can try and explain that. And you can get like a really nice numbered chart out of, and there is a library which does pretty much all of this. No, it is not built completely in-house. And then you can choose a feature that you want to influence. So let us say there is a particular dimension. In the loan example, let us say it is having or not having credit card. Then you can influence that and do a true what-if analysis. If you were to move from this point to this point, how would the result change? And when you're doing this, always keep actionable and non-actionable features in mind. So if you have ambient temperature, for example, that you can't control, there is no point studying that. This is a little bit more complex. Some of the data scientists in the room may understand multicollinearity. So we think things are independent. Nothing is truly independent. The butterfly effect holds. Butterfly flapping a wing somewhere has a correlation to other things. which means you cannot completely eliminate multicollinearity. Try to look for it in explanations. It has a big impact on explanations. Okay, back to Gen AI. So there are different approaches that we look at within our teams on how to tackle explainability in Gen AI. And so just to clarify, this is about Gen AI applications that we are building and using, not using Gen AI for interpretation. So different approaches that we use, one of which is human in the loop, I think talked about a little bit more earlier. There are local models that we look at. I'll talk a little bit on that. There are custom embedding models that we have, which help with the explanation, which I'll talk about as well. We have prompt sensitivity systems, and of course, RAG and citations. RAG is retrieval augmentation generation, the fundamental framework which pretty much everybody starts with. So this is how we think about LLMs and RAG. I'll need to go a little bit closer. I'm sure some of you have seen that. So you have a prompt or a query goes into some kind of a computer, which goes back into some kind of a model, gets an answer, and presents it back. Wherever you see the explanation mark is where in the background there is an embedding model being used. Embedding model is what converts the natural language into the mathematical framework which the model is able to understand. I think the slide is kind of lean there, but if I'm talking about blade, I did say blade earlier, right? So when I say blade, different pictures come in your mind. Some of you are thinking blade of a grass. It's a fair imagination. The razor blade that you use to shave, it can be a blade on the fan, it can be a blade in the engine. So there are different things which come into your mind. Language is the same. So when I say a blade, a model can say a blade of grass, it can say a blade of Gillette, it can say a blade of turbine. Depending upon how much data it has seen in the public domain, there is a very high chance it will say a blade of Gillette, because Gillette spends a lot of money on advertising. That is the data which you see in the public internet. There is very less aerospace data which is there outside, so low chance it will say blade of turbine. Again, I have a very specific, simple example, but custom embedding models using your own data allow you to understand your language rather than a language. So we all converse in English, but what you use in industry is not English. It is banking, it is healthcare, it is medicine, it is agriculture. So you have your own industry language, try to codify that. It allows for better conversational experience. So I'm sure everybody was fascinated with prompts when they came out and they wanted to have like, can I get my answer in one large prompt? But it is poor user experience at the end of the day. You don't want your users to write one paragraph to get an answer, one-line answer. You want interaction, but you don't want infinite interaction. Can we have transfer learning? Can you learn from one domain? I think pretty much everybody tries to do that. Can we compress the data? So custom embedding models allow you to compress the data because you don't need as big of a vector space if you have your own embedding models. It allows for better latency at the end of the day. And it allows you to personalize, which means you will sustain users. People will not simply go away because one time it thought blade meant grass and the other time it thought blade meant turbine. Okay, 5 minutes left, so I'll talk a little bit on AI governance. So these are key things which we keep in our mind. There is a safety policy. More or less every country has an AI governance and safety policy. Rolls-Royce has its own AI governance framework called Alethea framework. And we follow a process called digital product integrity, which essentially keeps reproducibility at its heart. So if for any application, if we are not able to regenerate, imagine a scenario like unfortunate incidents that happen, right? So if a situation happened and the regulator comes to you and asks, why did this happen? And can you make sure this doesn't happen again? If you cannot reproduce why did this happen, you are gone. You can no longer create an engine, you can no longer fly airlines. And it's a big thing for us to be able to reproduce things. Some references, so a lot of the pictures are from IML, Interpretable Machine Learning book. It is an excellent reference in case you are interested. PyCaret is a framework. Explainable dashboards, whatever I was showing, some of that is generated using PyCaret. I've given a reference to the Alethea framework, and the excellent picture of turbine was coming from the taxonomy of turbine blade defects. Of course, some of the pictures are from Amazon because you need to publicize your own book when you write one. All right, time for some questions. I have some questions here, so I'll probably go through some of them, and if there are still there, we can catch up offline. We still have 3 minutes, 3.5 minutes. So how to interpret hallucinations on non-RAG solutions? It's a good question. I don't think we have gone to a stage where we have any non-RAG solutions, to be fair. We are not trained a foundation model. We have not looked at a open model, which means a chat GPT, for example. How would you consider doing that? How did you end up in AI considering mechanical background? I think accident and choices, poor or good, depends upon where I end up next. But mostly a mix of accident and choices. Are there any scenarios discussed where we have been misinterpreting ML with AI? This is a very good question. I think, so SHAP, the paper came out in 2018. I was already working with data science in 2018, kind of looking for something like that. We were trying to build something of our own at that point of time. I was really impressed by the mathematical soundness of it. I think that if you have statisticians or mathematicians in your team, just have them go through that once, and that will tell you how good mathematics, sound mathematics still helps. I really like this one. Probably I'll pin it. How to scale SHAP models with many features? Yeah, this is a really good question. We should probably discuss it offline. This is a struggle which we run into as well. When you have this many number of features, I think there is a fundamental need for you to design your system better rather than just trying to solve it with SHAP. So even if you do it with SHAP, there are high chances these features are probably correlated to each other if they are from the same domain. So I would suggest not to build with thousands, hundreds and thousands of features. Keep it to a level where you're able to explain it. Okay, I think this is a complex question. I'll suggest if you go through the Alethea framework, some of the answers are there. And if you don't find it, reach out to me. I'm there on LinkedIn. By when do you think we'll be able to pinpoint what weight value led to what response in LLMs? Again, difficult question. We don't have real model access. I personally have not built a LLM on my own. So I cannot really answer by when we'll be able to reach to it. But again, there is some really good research coming out. The paper that I referred to from Meera Murati on non-determinism, it talks a lot about why there are different responses for the same prompt, which then eventually leads to what weight value will be getting used. Where does custom model? So custom models, embedding models allow you to reduce your space that you are working with. And then we have some proprietary methods to then, so with a reduced space, you can do more things, essentially. That is the idea. Okay, how much AI is good AI? This subjective question, so I will leave it to interpretation. Service-based companies, not look, again, more of an opinion. I think I'm running out of time. There are only 45 seconds left. So do you train separate models for each fleet type, or is there a generalized model that adapts? Again, context dependent. So for some instances, we have each fleet type separate models. And for some instances, like we are exploring physics-informed machine learning, where you have a generalized model which can explain any kind of fleet for a specific physics. That's 20 seconds remaining. I don't know if there is anybody in the room who has a question. I feel like I have covered a lot of the ones here. Any questions left?
We can pass on the mic if anyone just wants to stand up.
I really like this one, by the way. I think it sums up how I felt about machine learning when I started. Okay, looks not. So thank you, everyone.